Hello everyone, this is Mr. Kozlowski and welcome to Unit 5 on Waves. Today we'll be talking about Learning Target 1, which will be the first learning target of Unit 5. Learning Target 1 states that students will understand the properties of a mechanical wave. And there's three kind of sub-skills that students must perform in order to be successful at Learning Target number 1. The first of those skills is you must label the parts of a wave on a diagram. So the three big parts that we will be discussing are the wavelength, frequency, and amplitude of a wave. The second skill that you must do is you must connect these wave parts to the applications in light and sound waves. So you must be able to identify and apply what you learned about the parts of the wave and do that for sound waves and in light waves. And then last skill is you must explain the relationship between all of these parts, including speed and energy of the wave as well. So kind of a couple different skills, or three different skills that you must do. And once you get the hang of it and once you understand the vocabulary, it should be pretty straightforward. But before we get into that, we must understand what the definition of a wave is. It's not what you see at a football game. It's not saying hello to a friend with a hand gesture. Basically, in science, we determine a wave as a disturbance that carries energy and travels through a medium from one location to another. So basically, it's the way energy can travel. There's different forms of energy that we just got done discussing with Unit 4 towards the end of last semester. Now we're going to look at how that energy gets essentially transferred and travels through a medium. There's two types of waves that we need to discuss. Mechanical waves, which is when energy is transferred by vibrations of a medium. So basically a medium is another word for matter, so any type of material or substance that can carry energy through it is a wave. So example of this would be ocean waves. And then you have electromagnetic waves, which is energy that moves through disturbances in an electromagnetic field. Examples of this would be light waves, and we'll talk more extensively about these waves individually, or these types of waves individually, once we get a good foundation of what a wave is. The primary wave that we're going to focus on is our mechanical waves. This is kind of the lens we use to look through and look and study waves. And there's actually two types of mechanical waves. The first type is longitudinal waves, and these are waves that vibrate the same direction as a pulse or parallel to the pulse. So you can see that in this little graphic here, in this little picture here, you can see that there's a pulse, or a kind of a compression and an expansion going through the material here. These little dots represent particles, and we'll talk more about that later. The transverse wave is the second type of mechanical wave, and this is when there's a vibration perpendicular to the pulse, or basically up and down. So here you can see a transverse wave, that the source of the wave, the source of the energy, is moving up and down, but yet it still travels the same direction. So those are the two different types of mechanical waves we will talk about. The longitudinal wave, like I said, it's back and forth movement. There's a compression and what we call a rarefaction, or basically expansion of the energy. A good example of this would be sound waves and P waves, which are found in earthquakes, and we're actually going to look at earthquakes a little more closely later on in the unit during class. But a lot of the damage in earthquakes is caused by this compression and expansion of the ground, just due to the fact that there are longitudinal waves in earthquakes. Again, transverse, again, the sideways up and down movement. This is probably what you're more familiar with. Examples would be S waves in an earthquake, and then also many of the electromagnetic waves and light waves that we will talk about travel in this fashion. So those would be called a transverse wave. So again, we have the wave properties the things that you need to know and have a good definition for a base understanding of the learning target. What we have here is a transverse wave that if you can kind of follow it, and on a transverse wave you need to be able to identify these following properties. Amplitude is the displacement or height of the disturbance, or the height of the wave, and we measure that from this black line to the top of the wave. So this black line is actually called the origin, and then we measure amplitude from the origin to the highest point of the wave. If the highest point is above the origin, we call that a crest. If we can also measure amplitude from here to this point, and the point, the highest point below the origin, we call that the trough. So basically the height of the crest and the trough is what we call the amplitude. Wavelength is this disturbance between two consecutive points on a wave. So if we look at this height, this crest to this crest, it's two consecutive points, two of the same points in a row. So this distance from this point to this point, we call that wavelength. Frequency is the number of waves that pass a point per second. So this is a rate, or almost how often something passes that point, or how many wavelengths can pass that point. And frequency and wavelength are related to one another, and I'll talk about that relationship later. And then finally, velocity is the speed of a wave, and we will actually be doing a wave speed calculation as well in this unit for waves. So again, we have amplitude. Generally, I went over what amplitude means in this picture, but what does it indicate? It generally indicates the magnitude or the strength of a wave. So if we're talking about amplitude, let's say we're talking about a sound wave. Amplitude would be the volume. If you increase the volume on your stereo in your car, you are essentially increasing the amplitude of the sound waves that are traveling through the air in your car. Amplitude does not affect wave speed, and the other thing that it determines is brightness of light waves. So amplitude will determine how bright a light shines or how dull it can be. Wavelength, again, the distance between two repeating points on a wave, and wavelength is going to determine color of light and the pitch of sound. So if we look at color, all essentially color is how what wavelengths are being emitted by those particles, and you interpret that as color. So, and we'll talk more about that when we get to the electromagnetic spectrum. We'll also talk about pitch of sound. You change the wavelength of your voice, you're changing the pitch of your sound. Frequency, again, number of waves that pass a given point per second. The units basically are wavelengths per second, or we call this hertz. And again, it's related to pitch of sound and color of light. So frequency and wavelength are related in an inverse fashion, meaning if you increase the frequency, you decrease the wavelength, and vice versa. If you increase the wavelength, you're decreasing the frequency. Finally, velocity is the rate at which the energy travels with speed and direction. So it depends on the medium, and the medium is what the wave will travel through, or the material the wave will travel through. Mechanical waves travel faster through dense media, and we'll talk more about that later on in the unit, and we'll actually look at wave speed and media coming up here. And then EM waves actually do not need a medium to travel through. So that's why we will study electromagnetic waves later on, kind of separately away from the first few learning targets, because some of the rules change and the relationships change in terms of compared to a mechanical wave. So to review, the things that you need to know. Number one, you need to know the definition of wave, the types of waves, and then the wave properties. And once we get into understanding the wave properties, These are the basic premises of what you need to know. If you can define these four things, great. But like I said, there's a few more skills that you need to know, like understanding the effective frequency of wavelength on what light and sound waves, basically explaining the relationship between these properties and how they are affected in other types of waves. So we'll get more into detail later on in other learning targets and in class examples when we review this learning target, but understand these are the basic things. Again, if you have any questions, do not hesitate to contact me. Please take good notes on this, and also make sure that you take the online quiz that goes along with this. Thanks.